Hello everybody, this is Joseph Norman. Welcome to our 11th lesson with Pure Data. Today we're going to be combining a few of the different effects we've worked on over our last couple lessons, our ring modulation unit, our voltage control filter, and our variable delay. And we're going to work on combining them so that we can activate each one individually, basically with an on or off switch that we can control from our keyboard. Okay, and I'll show you how we can do that right now. So let's get started. First, we're going to create our ADC. And we're going to work with these send and receive objects, but we're going to be sending and receiving signals so that we can avoid having wires going all the way across the screen. So the first thing we want to do is create send tilde, and we'll call it signal. Okay. There we go. And so let's make our... Oh, we also should probably create a dry signal as well, since in this case I'll be plugging directly into my interface. You don't have to do that, although if you want to record, you would also want to then create a separate recording object and then attach the clean signal without any effects to the recorder in order to hear that during playback. Okay. So let's get started with just creating perhaps the clean signal. So I'll create a receive signal, and then let's move that over here a little further to the left. And then I'm going to create a signal multiplier, and I'm going to create a vertical slider to basically act as an on and off switch here. And we'll see how that works in a second. Let's go ahead and create, oops, there we go. And then we want to put a number box underneath of that. And then let's go ahead and create a pack 020. And then let's go ahead and create a v-line tilde. And then I'm going to create a couple message boxes up here. One that says 1, which basically will turn on our volume, and another that says 0. Okay, and let's go ahead and change some of the parameters on this vertical slider. We're going to keep lower as 0 and upper as 1. And say, okay, we can keep it as linear. Okay, and then after we do that, let's go ahead and create another signal multiplier. Let's just set the volume here as 0.2. That'll be our amplitude. Okay, so that'll change the relative amplitude of what's coming in and makes it better for mixing. That way we won't have too many clicks and pops if we have multiple things going on at once. And then after you make the recording, you can of course always normalize it in your DAW of choice. Okay, good. So let's go ahead and create our ring modulation unit now. So our signal. Okay, once again, we'll make a signal multiplier here. Move that down there. And this time, let's go ahead and create an oscillator. Let's say 4. Let's create a number box above it so that we can control the frequency of this oscillator. Okay, and then we're going to create a signal multiplier for it. And then we're going to create another number box, and that'll control the depth of our ring modulation. So the amount of, well, the relative loudness, I believe, of our sidebands here. Okay, and we'll attach that to this signal multiplier, and then we're going to make another signal multiplier here. And let's copy and paste our vertical slider that's going to be behaving as an on and off switch, and we'll attach that there. And then let's make another 0.2 for the amplitude. Okay. Then, next, let's go ahead, let's start moving these over to the left a little bit more even. Okay. Next, let's create another R signal. Okay, and let's go ahead and make our voltage control filter. So, VCF tilde, just some placeholder values here. Okay. And that will go there. The next thing we want to do, let's go ahead and create our addition signal box. And then let's go ahead and create another oscillator, placeholder value. Okay, and then we're going to create a signal multiplier. And then we're going to create another number box. We'll attach that there. And then we're going to create a number box that will go into the addition box here. We'll attach this to the middle inlet of the VCF. And then we're going to create an extra number box here. And that will go into the Q, the resonant peak for our voltage control filter. And then let's create a number box up here to control the oscillation. Okay, so to recap this, we have our center frequency for our bandpass filter that's coming out of this VCF object, and then we're using this oscillator as a control to basically modulate up and down around that center frequency, and we can control the rate of speed there. The depth of the modulation here, this will change it basically to be louder or more pronounced of an effect. And then we have our resonant peak here, so that this will narrow the band of frequencies for the attenuation of the filter. So when it's at 1, you're actually getting closer to a kind of all pass with a higher peak around the center frequency. And when you put it up to 10, you have much more attenuation and mostly just frequencies coming from the center or around the center. Okay. And then we want to create our signal multiplier. Yeah, let's move this up a little bit. We want to copy our vertical slider. Attach that here. And then we're going to create another signal multiplier just for our amplitude, a relative amplitude coming out of this signal here for this effect. Excellent. And then finally, let's go ahead and create our delay unit. So let's go ahead and make an R tilde signal. Okay, and we can just put this up here a little higher, and then we can create our del right tilde. And let's just call it D left. Oh, and we need to set a time frame there, say 4,000. And then duplicate that. And now it's D right. We'll attach those, and we can just attach that signal to both of those. Let's move this over even more. And then we're going to create our VD tilde, and we call it D left. Move that over here, and then duplicate that. Call it D right. Okay, and then let's go ahead and create pack 0, let's just say 500. and then have that attach to a V line, tilde. Put that there, and then we want to be able to control the delay time. So put that there. Let's duplicate that. Run that over here. Move these down a little bit more. Just a little separation between them. Alright, and then let's go ahead and create a low pass filter so we can have our feedback control. Run that in there, duplicate, run that in there, and then we want to create a signal multiplier. And in this case, we can do the same thing that we were doing before for this. Run that there. Here, and in this case, let's change the properties. We don't want it to go to 1 because we don't want feedback to get out of control, so we're keeping it at 0.99. And then let's duplicate all of that. Maybe move this over a little bit more here. So there's a little bit more space. Run that there. Okay, and then I'm going to create another send signal. Again, so we don't have wires all over the place. I'm going to say DFL for delay feedback left. And then I'm going to copy that. And then say DFR for delay feedback right. And then I'm going to, up here, create a receive tilde for DFL. And then I'm going to copy that. And this will be DFR, so we're feeding these back into our del rights. And then we want just the dry delay going to the output. So next, we're going to want to create, whoops, don't want that up there. We're going to create a signal multiplier here. Let's move this over. It's not super spacious. And then another signal multiplier, maybe here. Move these down a little bit more. Maybe move these guys over here a little further to the left, so we have a little bit more room. And then we'll do the same thing here. Okay. And so what we want to do next is we want to take these modules here, these V lines, and oops, we don't need that. We want to run that in here, and then we want our variable delay going directly in there. Okay, and then we want to copy that again. There, there, good, and then let's go ahead and create a signal multiplier for the mixer, 0.2, 0.2, and these go into the left and right channels respectively. Okay, good. So the first portion of our patch is complete. So next, we will work on developing the keyboard controls here to be able to turn the on and off switches, basically. So we will be using send and receive objects for that, as well as the key object. Before we start all that, let's tidy this up a little bit. So we can move these feedback controls up a little bit higher. Maybe move this here. Good, that gives us a little bit more room. We'll do the same thing here. And then we can move this up here a little bit. There we go. That's there. And we'll move that there. Actually, and this should probably come down just a little further. Move that there. Okay. All right, so the first thing we want to do now is create a key object and a number object. And so now, when we press a key, for example, if I press the A key, we'll see that it comes up with the number 97. These are the ASCII values. S is 115, D is 100, F is 102. Okay, so let's just start with 97. Let's say we want to use our A key to send a bang, and we want it to press 1 for our clean signal. So to turn on our clean signal, we can create a select object, 97, and then we would say send clean on, for instance. Okay. And then let's say we want it to turn off the clean signal. Well, let's go ahead and copy just the key and the number. And then let's see what happens when I hit W or Q. Let's do Q. 113. So create a new object, select 113. Send clean off. Okay. So we're going to want to make each of these, one of these for each of these effects. So let's duplicate, and then we'll change the specifics as we get to it. Okay. So for example, we want to change or activate our ring modulation. That's 115. Let's change that to send 115. And we'll say send ring on. Okay, and W is 119, so we'll say select 119 and send ring off. Okay, let's see, D. We want to say filter on, and D was 100, so select 100. E is 101, so let's say select 101, filter off. Okay, and then F is 102, so we'll say 102, delay on. And then R is 114, so select 114, delay off. Okay, so then all we have to do here is create some objects. We'll create send clean on. Oh, I'm sorry, receive clean on is what we want. And then we want to create another receive for clean off. So we'll create receive clean off. Okay. And then let's go ahead and create a receive for ring on, and then a receive for ring off. Okay, and then let's go ahead and create a receive for filter on. And a receive for filter off. Okay, and then let's create a receive for delay on. And delay on is going to go to two places. It's going to go to the left and to the right channels. And then let's create a receive for delay off. Let's move that over a little bit to give us some room. And that's going to go to our off switches there. Okay, and let's just test these out. So it looks like we've already inadvertently activated our clean on signal, so we can hit Q, and that turns it off. A turns it on. S activates our ring modulation. W turns it off, as you can see here. D will activate our filter. E will deactivate it. And then F will activate our delay. And R will turn it off. And then, of course, you have to manually control the amount of feedback that you would like. Okay. So let's go ahead and finish out the patch by sending our signal, our last bit of signal, out to the DAC. And then we'll also create a little recording unit. Okay, so here we go. DAC. And then I'll also create a write SF tilde. All right. So we'll send clean signal out to both channels. The ring modulation. Whoops. Out to both. The filter. Out to both. And then we will send the delay to the left and to the right for it to pan. And then I'll just work from right to left this time, so should make that right SF2 for stereo. So we'll send the delay to the left and the right. We will send the filter left and right. Send the ring modulation left and right. And send the clean signal left and right. Okay, put those up there. Let's create some messages. Start and stop for our recording. And then rename a file. Open. We'll just call this effects.wave. Put that there. Move that up a little bit. Move that one up a little bit. Okay. So next I'm going to create some preset values here for our ring modulation and our filter and our delay. And I'll play you a little example of what that sounds like with the guitar.